Okay, so I'm going to solve the two problems that I assigned as special problems from 2.3. The first one asks you to calculate the inverse of, or verify this matrix invertible, and then if it's so, then find the inverse. And do using the method of the adjoint. So I repeat, this is by the formula. The inverse of A is you take the adjoint of A and divided by the determinant of A. This of course means that the determinant of A should be non-zero. So let's start with the determinant of A. So the determinant of A, that is 2, 0, 3, 0, 3, 2, minus 2, 0, negative 4. I could do row reduction, but I see that it's actually much easier if I just do expansion along this column. So I use column 2, taking into account always the pluses and minuses. Okay, by now perhaps you can recognize this. It's going to be a plus here because we're going to do expansion with this element, right? So we get 3 plus 3, but I'm not going to write that. And then what's left is 2, 3, negative 2, negative 4. So that is 3 times product is minus 8. Subtract this product, minus 6. So that is 3 minus 8 plus 6. That is 3 times negative 2. That is negative 6. So that's non-zero, so we know our method is going to work. We have to now just calculate the adjoint. It's a bit of work because we have to calculate 9 determinants, right? We have to calculate all the cofactors. Okay, let's start doing that. They're all 2 by 2 matrices, just not too much of a work. Okay, all right, so let's start with, well, let's just start C11. This would be obtained by the C11. We're talking about this element, so I just do these two, scratch this out, and I have to just find the determinant of what's left. And what is the sign? Well, it's a plus sign here, right? This is here because of the plus sign. Okay, so what I've left was 3, 2, 0, negative 4. That is negative 12. There's nothing on the off diagonal. All right, so let's keep going. C1, 2, I don't know in which order to do it, I just take. So C1, 2, I'm actually talking about this guy here now. So that's with this guy, so this would mean I'm gonna delete this and I'm gonna delete this. 0, 2, minus 2, negative 4. So 0, 2, negative 2, negative 4, that's what I said, but I have a negative sign, so minus here. Don't forget the sign, okay, because that's gonna make the difference between right or wrong. Okay, so minus, this product is 0, and the other one is subtract from that negative 4, so that actually is negative 4. C13, talking about this, and therefore what's left is 0, 3, minus 2, 3. So 0, 3, negative 2, 0. Sorry, I said it wrong. The sign is positive here again. We are dealing with this sign. There's nothing there, and it's minus, subtract from that 0 if you want, minus this negative 6, so there's 6. This is very easy to forget that there is a minus here, right? Because remember in the formula, one more time, for those that are not convinced, that's the formula here. So there's a minus here, we subtract it off diagonal. That's what goes to these negatives. Okay. Right, so C21, make sure that I have all 9. C21, second row, first column, so we're talking about this. So we do this, 0, 3, 0, negative 4. Okay, that's not 0, 3, 0, negative 4. What's the sign? It's a negative sign, so negative. Now you see that this is a 0. You could see this also already here from this row, right? If you would expand along this row, it would be 0, right? So okay. So C22, let me get myself a little bit more space here. C22, I'm talking about this. This corresponds to a plus sign, and therefore what's left is 2, 3, minus 2, negative 4. 2, 3, negative 2, negative 4. That is negative 8 minus negative 6. that is negative 8 plus 6, that is negative 2. C2, 3, I have to do that one, corresponds to getting these guys out. We see again that we have a 0 row here, right? This is the 0 row, so I know already the answer is going to be 0. So I'm going to go a little bit faster now, because otherwise it takes forever. Okay, so I hope everybody sees that why this is 0. Now let's do the last row. So we're talking now about this guy, but it's left 0, 3, 3, 2. 0, 3, 3, 2. I have to think about the sign. I didn't make my whole sign pattern. Minus, plus, minus, plus. So we are, oh, what we are doing? C3, 1, right? Yes, I don't know what happened to my 1 here. Yes, this 1, yeah. Okay, so we have plus sign. This product is 0, and this other product is 9, so it's negative 9. And then finally, let's see, I have space, right? So I do, oh no, I don't see my matrix anymore. Okay, so let's squeeze it somewhere in here, C3. Oh no, I have to do 2 more, so let's do it again. So C3, 2, what is that? Well, let's go. C3, so we are third column, second row, 2, 3, 0, 2. 2, 3, 0, 2, right, that's correct, yeah. And what is the sign? It's a negative sign. So we have a negative here. So this would be negative 4 because the other diagonal is 0. And then C3, 3. Okay, this is again with a positive sign, and this is now the positive sign here, and this is 2, 0, 0, 3. 2, 0, 0, 3. And that is just 6. Okay, so we can write down our adjoint matrix. It's the matrix that you obtain by now plugging all these elements in there. So let's make sure that we don't forget any. C11, 1 position 1, 1, that is this one. C12, first row, second column, so that goes here. C13 goes here. C21, which is 0, this is second row, first column, so it goes here, 0. C22, that's negative 2, that goes here. C23 was also 0, right? Okay, yep, good. What else? So we did this one. C31, that's third row. We're talking about the element here, so that's negative 9. C32, negative 4, and then C33, 6. So that's my adjoint matrix A, and therefore my inverse matrix. Remember the determinant we had already defined was negative 6, would be 1 over negative 6 times this matrix. It's easier to write there, although you see many elements are actually divisible by 6. But if I would write down, if I bring the minus 1, 6 inside, I would still have fractions. Let me just do it so that you realize what it is, because perhaps sometimes people get confused about this. What it means is every single element has to be now multiplied with minus 1, 6. So minus 12 divided by minus 6, that will be 2. Minus 4, 6, minus 4 over 6, that will become 2/3, right? Okay, so I'm going to write just 2/3 here. Minus 6 divided by 6, that's negative 1. Of course, this is just 0. This is going to be minus 2 divided by negative 6, that's going to be 1/3. I hope you see that. 0. Minus 9 divided by minus 6. So minus 9 divided by minus 6. If I simplify this, it will be 3/2. Minus 4 divided by minus 6, that is 2/3. And the last one is negative 1. So that's actually inverse of the matrix. Okay, that's the first problem. You see, it's a bit of work, but nothing too hard. You just have to be very, very careful with the negative signs and putting everything right. Oh no! Oh! Guys! You should have made a mistake, right? The adjoint is the transpose of this matrix. So I have to still take the transpose of this matrix, so I still have to take the transpose. Yeah, I keep forgetting that. Okay, so it's the transpose of this matrix. And what is that? So now we have to still transpose. I could do it in the in this form, but let me do the form that I have now. That is 2, 2/3, negative 1, 0, 1/3, 0, 3/2, 2/3 minus 1. So that's the answer. So don't forget the transpose. What I did was I almost forgot. Okay, so let me remind you, this means transpose. Okay, and so now you could check that if you multiply this matrix with the original one, you should get 1. Let's just verify this at least for one element, that if we are we completely off or not. So the matrix was 2, 2, 0, 3, 0, 3, 2, I'm copying it from somewhere else, and minus 2, 0, negative 4. So I'm just going to verify that I do get the identity matrix. I'm not going to work out everything. Let's just find out, so this product here, let's calculate this element here. It's perhaps a good review. How do you calculate one single element there? Well, so this element is in the first row. So we're gonna, for the first matrix we take, in the third row. So from the first matrix we take the third row, and it's in the first column. So from the second matrix we take the first column. And now we multiply. Remember how it goes. We multiply this element with that, and this negative 2. This element with that, and add it to it, 0. And then this element with that, negative, negative is plus 2. So this comes out 0. That's good, right? Because this has to be the identity matrix. So at least one of the elements is correct. You can now check the other ones. Okay. Well, let's do perhaps one more. Let's do also this one. So it will be still the same row, but this time a different column. We want to do this column now with this row. So we have minus 1, 3. So this would be negative 3. This 0, of course, doesn't do anything. And then negative 1 times negative 4. So this would be minus 3 plus 4, which is 1. Again, what we would expect there. We need a 1 there. And the other one's elements will fit now too. I'm pretty confident I did it correct. Okay, so next question. That was number 27. And this was about Cramer's rule. So we had the system 3 by 3, x1 minus 3x2 plus x3 equals 4, 2x1 minus x2, right, let's see that I don't copy this wrong here, equals negative 2, 4x1 minus 3 times x3 equals 0. So the matrix that we have, the matrix A, is the matrix 1, negative 3, 1, 2, negative 1, 0, 4, 0, negative 3. Okay? And in this method, we know that xi, the solution, is given by the determinant of ai divided by the determinant of a itself. And ai is a replace in, so let me say it a bit differently, in a replace column I by the constant column. So the constant column when I'm talking about is this guy, by the constants. Okay, so let's start with A itself. And since I don't want to expand here, I'm going to do row operations just to practice that. So let's write it this way. So I have to do 1, negative 3, 1, 2, negative 1, 0, 4, 0, negative 3. There are many ways to do this, and I just want to do a little bit different than we normally do. Don't do this if you don't understand how to do. Just do your usual way, but to just show you that there's a lot of freeway, but you have to be very careful with this thing. So what I'm going to do is actually I'm going to say, well, look, I have a 1, that's a pivot. I have already a 0 there, so I only need to worry about this guy. So what I'm thinking of now is doing the following row operation. Replace row 3 by row 3 plus 3 times row 1. You would normally work with this pivot and try to make these two guys 0, but I'm going to do it this way. And I'll show you that it works as well. If you don't like this method, then just stick to the usual one. Okay, so what we have, so by the way, this doesn't change the determinants. I can write minus 1, 3, 1, 2, minus 1, 0, nothing happens. So what I'm doing, I multiply this with 3 and add it to there. Okay, so minus 3 plus 4, that would be a 1, 9 plus 0, is 9, minus 3, yeah, sorry. No, I said it wrong, right? So be careful. I have to multiply this with 3 and add. Sorry. So this is times 3, that's a 7 here. That is negative 9, and this would be 0. Okay. Now, I can expand, but of course you have to be a bit more careful now. We are expanding now along column 3. And so we have to double check whether we have the right signs here, plus, minus, plus. So it's again a plus sign, good, that's good. So that means I will have a 1 here, I have the 1 here, and then erase these two guys. What is left is, well, let me not use this color, because I think in some browsers it might come out a little bit. Okay, so that's what's left, and so that is minus 18 minus 7, okay? So that is minus 18 plus 7, that is negative 11. Okay, so that's the determinant of A, which is non-zero. Otherwise, of course, this formula doesn't make sense if the determinant is 0. Okay, but that's not the case, so we're good. All right, so so now I have to calculate A1. I need some, I don't think I can here, yeah, A1. What is A1? Well, A1 is obtained by delete this row and replace it by the constants, by this row. Okay, so let's do this, work this out. So I'm going to write, copy just the whole thing. And now I'm going to delete the first row and put in the constants. I'll keep my purple. The constants were 4, negative 2, 0. 4, negative 2, 0. Okay, and let's let's already do the other two. A2 is, now you keep the first row. We're going to delete the second row and instead put the purple guys. So 4, negative 2, 0. And then we keep the third row. 1, 0, negative 3. And finally, A3. Same principle. Now we do get rid of this guy, so it's 1, 2, 4, negative 3, negative 1, 0, and then our purple guy again. That is pink, purple. 4, negative 2, 0. There we are. Okay, so we have to actually calculate the determinants of all these matrices. It's a bit annoying. Well, the first one is actually not so bad, right? The determinant A1, do you see how to do it? Think about it. If you don't, I'm going to use row 1. Because I have a lot of zeros, so this would be, I have to think about the signs. So this is a plus sign, minus, plus, minus, plus, so we have a plus sign. Negative 3 times what's left, 4, negative 3, negative 2, negative 1. Get a bit worried with my plus and minus that I didn't do. Okay, yeah, that's correct. Okay, so that is minus 3 times negative 4 minus the product is 6. So that is minus 3 times minus 10, that is 30. Okay, so x1, I know already what x1 is, but let me do everything now once and then I will put it all together. Determinant of A2. Okay, now I don't have a beautiful row or column, so let's do row reduction here. Oh no, let's do expansion along one of these rows. Let's take expansion along column 3. I like to take columns with zeros in as much as possible and with small numbers. That's why I chose this one. But you can choose something else, okay? So plus, minus, plus. So we have the 1, this element. And what is left is 2 minus 2, 4, 0. 2 minus 2, 4, 0. Minus, plus, plus. Now this element, negative 3. Times what's left, 1, 4, 2, negative 2. Okay, so that is 1 times, that's a 0 minus 8, plus negative 3 times negative 2 minus 8. So that is, that was 1 times. Minus, that is plus, so that is 8, plus, and here this is minus 10 times minus 30, minus 3, that's plus 30, so 38. Okay, and then finally, determinant of A3, I'm going in good shape again. You see why? I'm going to do row 3, because there's only one 0 here. So plus minus plus, so this element is just with a plus, and then I'm left with negative 3, 4, negative 1, negative 2. That is 4 times 6 minus 1 times 4. Well, why do I write this? Let me just work it out. Minus 4. Okay. So that is 10. So this would be 4 times 10. This is 40. So conclusion, x1 is determinant of A1. Right, so this is we're using now this formula here, right? For all the 3 variables. X1 is the determinant of A1, which was 30, divided by the determinant of A. That's always the same, and we had calculated the determinant of A. Where did you go? Right, determinant here. This was the determinant of A, negative 11. X2 is the determinant of A2, which was 38, divided by the same negative 11, and x3 is the determinant of A3, which was 40, divided by 11. So that's the solution, and there's only one solution because the matrix is invertible. What I want to say perhaps quickly is, although this is a bit cumbersome method, you see that the answer involves fractions. So if you're going to do row reduction, that's the more common way of doing it, and probably faster, you will end up with fractions, where in this way I actually avoided any fraction, except for at the end I wrote them down. All right. So yes, so this is that's it.